This video is going to go through the process of solving a couple Newton's laws problems using your force diagram and your F-net equations. For the first problem, we're going to look at an object that's falling. There's going to be air resistance. So the force of gravity on the object is 10 newtons. The object is falling at terminal velocity. So that's a very important point. Terminal velocity, or constant velocity, means that the net force on the object is zero. So our task is to find the force of air resistance. It may look complicated, but it's actually quite simple if we follow the correct process. So here we go. Let's start as we've done so far. We know that we're going to have the force of air minus the force of gravity So here we go. Let's start out. We first start out with writing out our F-net equation. We've already established the diagram where we have force of air pointing up and force of gravity pointing down. So the next task is to write the F-net equation. So we write F-net. Well, it's moving at terminal velocity. Or, we know terminal velocity is a constant velocity. It's the fastest it can get going. So that means F-net is zero. So then we start writing, what is F-net? Well, F-net is the force of air. Whoops, that's AIR. Minus the force of gravity equals zero. Now we input everything we know about the problem. So everything that we know about the problem is we have a 10 Newton force of gravity. So force of air minus 10 newtons equals zero. Well, that tells us that the force of air resistance is equal to 10 newtons. Okay, in this problem, we see that we have an object and it's accelerated to the right by a 15 Newton force. If its velocity changes from 5 meters per second to 15 meters per second in 20 seconds, what is the object's mass? This seems like there's a lot of things that are unrelated here, but they're not. So the first thing we want to look at is we're going to draw a diagram of the object. So if we draw a diagram, we know that we have a force pushing it that way. We also know that we always have force of gravity. In this case, we would have a normal force acting upwards on it. So from this diagram, we know that F-net equals mass times acceleration. We also can look at the diagram and see that the F-net is going to be F minus 0 because there's nothing on this side of the diagram acting against the force that we've applied. So that is equal to ma. Well, we know that this force is 15 newtons equals mass times acceleration. We're looking for the mass of the object. Since we don't have it, we're going to have to find it some other way. Well, if you notice, we have some kinematics information. So let's take a look at what information we have from kinematics. We have VI, VF, D, A, T. Well, the problem states that we go from 5 meters per second to 15 meters per second in 20 seconds. All of these problems, the link between solving the problem is going to be acceleration here and acceleration there. Time out. While making this video, my camera ran out of memory. So let's take a look at finishing up this problem. So where were we? If you look, we left off with saying acceleration is the link between the kinematics problem and the Newton's laws problem. So we're given a Newton's laws problem, but we have to solve a kinematics problem first in order to get acceleration so that we can find the mass of the object. So let's look at how we did that. We went through our VIFDAT. We find that we use equation 1. We use equation 1 to solve for acceleration, which is 0.5 meters per second squared. So now we can go back up to our kinematics equation, which is 15 equals mass times acceleration. So we have 15 equals mass times an acceleration of 0.5. We divide both sides by 0.5, and we're left with the mass of the object has to be 30 kilograms. Okay, let's move on to another problem. So let's look at finishing this problem. I'm not sure where I left off when my battery died again. So here we go. To recap what we had, so we have a Newton's laws problem where a box is pushed across the floor against 10 newtons of force of friction. The box starts from rest and is moving at 4 meters per second after 10 seconds. What is the force applied to the box? The box is 5 kilograms. So we started with writing an F net equation. So F net equals mass times acceleration because we know it's accelerating. So what is F net? F net is F minus the force of friction equals mass times acceleration. If we put in everything that we have, we get force minus 10 equals 5a. So we still have an unknown variable of acceleration. So for that, we've done a VIFDAT problem. So we have VI, VF, DAT. We use equation number 1. Velocity initial 0, so velocity final is just AT. So velocity final of 4 equals 10a. So acceleration is 4 divided by 10, or 0.4 meters per second squared. Now that we have acceleration, we can go back to our Newton's laws equation, second law equation, and we have F minus 10 equals 5a. So we have F minus 10 equals 5 times 0.4 from here. So we're left with F equals 10 plus 2, or 12 newtons.